Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika, welcoming all my grade 11 advanced students who are going to give the upcoming term 3 math exam. Again, I'm back here on my channel with an FRQ revision video for the coming term 3 EOT exam coverage. Today we are covering learning objective 16, where you convert between polar and rectangular equations. This is a long and very important question with a lot of things that are being asked. So first, you need to identify the graph of each rectangular equation. So for some of these questions, we have topics from term 2 that will be helpful, like conic sections. So we will have parabola, hyperbola, ellipse, circle, lines, all of that coming. And then we need to write the equation into polar form. We convert, so we use x equal to r cos theta, y equal to r sin theta for that conversion. Then there's a little bit of algebra that will also come along with trigonometric identities. So if you remember your term 2, we had done a lot of list of identities of trigonometry. We are going to use them to simplify and give the final answer. So I would highly recommend you to revise your term 2 portions, especially learn the formulas so that you can solve this question um, correctly and get full marks. Trigonometric identities like Pythagorean, reciprocal, quotient, all of those are going to be used for solving. So let's get started and see what questions we are solving today. Okay, so let's solve the first FRQ question, which is from Learning Objective 16, where we need to convert between polar and rectangular equations. So this is a long question FRQ. Possibly it will come for 6 to 10 marks, so you need to show all the steps nicely. Now there are a lot of things which are being asked in the question, so let's read the question one by one. The first thing is to identify the graph of each rectangular equation. So in this part, all the equations are in rectangular form, means they are in the form of x and y. So first we need to identify based on our term 2 portions which rectangular equation represents which graph, and then after that we need to convert based on term 3 chapter 8 polar coordinates into polar form. So remember, whenever you get a question to convert from rectangular to polar, means we want to convert from x and y to r and theta. Always substitute x as r cos theta and y as r sin theta. This should be step 1 when you are converting to polar form. After that, in the next part, you need to do the graph of the polar form, and then you need to check your answer whether it is the same or not. Support your answer. So let's look at this rectangular equation, which is very simple, x equal to minus 2. So if you go to rectangular form, then this is a straight line, a vertical line which is passing through the coordinate -2. So if I want to just draw this line, then this is my x-axis, this is my y-axis. Right now I'm looking at the rectangular form. So -2 will be here on the negative side. So my line x equal to -2 will be passing through this. So this is my um, x equal to -2 line, which is a vertical line passing through the point -2, 0. Okay, this is the first part where you identify the graph. So you can write it's a vertical line passing through the point -2, 0. So first is done. Now we need to convert to polar form. So as I have already explained to you, always when you have to convert to polar, use this formula. So I will put in place of x, r cos theta is equal to -2. Now I want to convert to polar form, means I want to isolate my r. I want to keep my r separate. So I'm going to move the cos on the other side. On the left side it was multiplied, so when it goes on the right side it will be divided. Or alternatively, you can divide both sides of the equation with cos theta. So you get this. Now use the reciprocal identity. From term 2 trigonometry, 1 over cos theta. See, remember, whenever a trigonometric ratio is in the denominator, means you have to take its reciprocal. So I hope you remember the reciprocal of cos is secant, so -2 secant theta. So the final answer for the polar form is r equal to -2 secant theta. Now this is polar form because it is only in terms of r and theta. Now coming to the graph of the polar form, in this equation, if you see carefully, you are given the value of r in terms of theta, so you can take different angles. evaluate this function r equal to minus 2 secant theta for different values of theta, different values of the angle in the domain, and use these points to graph the function. Then the graph of the polar equation will come out to be like this, the same straight line. I will show you the polar graph in the next slide. Now let's do one more question. Here if you see, this equation has squares, it has addition, so this resembles the equation of a circle from term 2 when we did conic sections. This is how I can rewrite this equation. So I hope you can compare for the circle, the center, and the radius. So what is that? Let's see. So my h is going to be negative. My k is actually nothing here, so 0. And this is my value of r square, so r is going to be 5. So let's write h comma k, the center of the circle is going to be minus 5 comma 0. And the radius is going to be 5 units. So definitely if I want to draw the graph of this rectangular equation, it represents a circle with center minus 5 comma 0 and radius as 5. Okay, so you can always draw it. Go to the rectangular coordinate. Minus 5 means it's here. This is my center. Take the radius as 5, so it's going to touch at 0. This is my negative x, this is my positive x. And if I want to draw my circle, it's going to be in this way. Yeah, so center is this, radius is also 5. This is my rectangular equation of the circle which is given. Now I need to convert to polar, so I'm again going to do the same thing. I will replace my x with r cos theta, y with r sin theta. So let me go to the next slide and show you how to do that conversion. Now I'm going to do the conversion of this given rectangular equation to polar form. So I'm going to replace x with r cos theta, y with r sin theta. I'll also take the help of a little bit of trigonometry from term 2, and also I'll take help of algebra. I'll be using this identity. So let me write for you first, and then we are going to use it to simplify and reach to our answer. So I'm replacing x with r cos theta. This becomes my first term, y with r sin theta, and 25 as it is. Let's try and simplify and see what we get. If this is my first term, this is my second term, then this identity is going to expand in this manner. So the first term, r cos theta square plus 2 times the product of the two terms, I multiply, and then for the second term I take the square and I open this r sin theta, so this power 2 distributes, so it's like r square sine square theta. There's 25 on the right, which is unchanged. Now I open the first term, again I distribute the power, so this becomes r square cos square theta, and I'm going to combine it with this term. Why I'm combining it this way, you'll just get to know in a minute. Now 2 multiplied with 5, that's 10 r cos theta. So this whole term gets multiplied. 5 square is 25, and there's a 25 on the right. So to simplify, I may cancel this, nothing on the right, so it's 0. And now, why did I take these two together in the same bracket? The reason was because r square I can take common. And when I do that, inside I'm left with the Pythagorean identity. So now, let's see how much you remember from previous term. How much is sine square theta plus cos square theta? I'm going to write it here. Whatever identities, whatever formulas I'm using while I solve. So all of this you need to mention clearly what you're using. So this becomes 1. So I'm left with r square times 1. I'm going to move this on the other side, becomes negative. And now just to simplify and give the final answer, because r is common, I'm going to divide r on both sides. R gets cancelled. There's just 1 r left here, minus 10 cos theta. So this is my polar equation. Remember, whenever you are giving your polar equation, the final step should give you the value of r. And now if I compare it with the standard form a cos theta, I'm able to see that my a is negative, less than 0. So this circle is going to be on the left with a diameter of 10 units. So let's see how the graph looks like. Actually, we had also got the same thing from the rectangular part which we solved in the previous slide. So let's now evaluate this function. R equal to minus 10 cos theta for different values of the angle theta in the domain, and then use these points to graph the function. And we already know that the graph is going to be a circle. So let's see the final graph for both the questions now. Now you can see the final graphs for question 26 and 27. For 26, which was given to be a straight line x equal to minus 2 in the question. So we converted into polar form, and this is how r equal to minus 2 secant theta will look like. Here we can make the table of values for r and theta, take different values of theta and calculate your r using calculator. And this is how the graph will turn out for 26. For 27, the graph was a circle. So this is the equation r equal to minus 10 cos theta, and the equation that was given to you in the question was rectangular x plus 5 whole square plus y square equal to 25. So both the graphs are same, so therefore we have verified our solution. The graph is correct, and whether it is rectangular or polar, we are going to get the same answer. Make sure you solve all the steps as I explained to you. Let's practice some more questions, one on parabola and another on hyperbola. Okay, let's now solve question 29. Here the graph is a parabola, as you can see. From your knowledge of term 2, the graph is going to be a parabola. This is rectangular equation given. And to find the polar form of this equation, we need to do the same thing. Replace x with r cos theta, y with r sine theta. This is what we are doing always. Let's plug in here. So on the left side we get r cos theta, on the right side there is square, so I put r sine theta and do the square. So again I open this, simplify. This is r square and sine square, there is r cos theta. So let's see what we can cancel on both sides. Definitely it's an r. I divide both sides with r, then this cancels, simplifies, and we are left with r here with sine square theta. Now I always told you before also that when you convert to polar, r has to be isolated. So keep the r here, remove the sine. So I take sine on the other side and divide by sine square. Now to simplify this and to use a little bit of trigonometry, I'm going to break this sine in two parts. So one sine I will take with the cos. So that's cos divided by sine, and another sine I take separate. Nothing is there means it's like multiplied by 1. Remember, whatever is in the denominator you can always take reciprocal. So now if you see, this is multiplication of two terms. One is this cos divided by sine. So I can replace this using knowledge of term 2 trigonometry. Cos divided by sine is quotient identity converted to cot, and 1 over sine means reciprocal of sine, which is cosecant. So this is my final polar equation. So you must be now agreeing with me when I say that knowledge of term 2 trigonometry is also essential for solving these problems. And now we just move to the last part where we do the graph. Graph is going to be the same like a parabola, which is symmetric about the polar axis. So when you do the graph, you can take different values. This is the polar form. So take different values of angle theta and you will get different values of r. You can take 6 to 7 points. For example, I start with 0, then I go to 30, then I go to 45, then 60, 75, then 90, like that. So here I have taken divisions of 30 or 15, whatever you want to take, you can take it and put this in your calculator. You will get the values, you will get the points, then join the points and you will get the graph. So let me show you in the next slide how the parabola looks like for the polar form. So this is how the graph is going to look like. This is the final graph for x equal to y square question. This was the rectangular form, and when you convert to polar, you got r equal to cot theta cosecant theta. Now some of you would be wondering how we get the point. I would again quickly repeat, you will get the points from the table of values. So calculate your r from the calculator by taking different values of the angle or theta. When you change the theta, you get different values of r. Plot the polar coordinate r comma theta, take all those points, like this is one point, another point, another point, then because of symmetry you have the same points, join the points and what you get is the parabola. So this is how the parabola looks like. Definitely it is symmetric with respect to the polar axis. Now moving on, we will do one more question. This is on hyperbola from term 2 again. You can compare the equation x minus h whole square minus y minus k whole square equal to r square. So if you see the differences of the sign, for circle it is positive, for hyperbola it is negative. So now we do the conversion to the polar form. Again, I'm using the same formula. I replace x with r cos theta, y with r sin theta, and then do a little bit of algebra. But this time I'm going to use negative as there is negative sign. So a minus b whole square, a square plus b square minus 2ab. This I'm going to use. I will also use a little bit of trigonometry. So let's simplify and see what we get. So here it is r cos theta minus 1 whole square minus r sin theta whole square equal to 1. So let's open this up. R square cos square theta plus 1 minus 2 times r cos theta, and here I also have r square sin. Now I'll not be able to use Pythagorean, but still I can combine these two because r square is common, and this time I get cos square minus sin square. 1 and 1 is going to cancel. This I'm going to move on the other side, so it becomes positive. Now what can I divide? Both sides r is common. Divide by r. This r goes. 1 r is remaining here, so in next step of simplification I'm left with r multiplied with cos square minus sin square is equal to 2 cos theta. Now I can convert using trigonometry again. I will use the identity for double angle cos 2 theta. Cos of double angle is cos square minus sin square. So let's replace this here. So I'm left with cos 2 theta is equal to 2 cos theta. Now I will repeat the same thing. When we give final answer for polar form, I want to isolate my r, just keep it alone. So this cos 2 theta I'm going to remove. So I divide with cos 2 theta or the double angle identity on both sides. Now let's see how I'm going to do a little bit of modification to my final answer. 2 cos theta is already in the numerator. I'm not going to change it at all. So this numerator is as it is. Now remember, whenever you have a trigonometric ratio in the denominator, like this 1 over cos 2 theta, it's just like taking reciprocal. So we'll take the reciprocal of cos 2 theta. And I hope you remember from term 2 that the reciprocal of cos is secant. So this will convert to secant. So your final polar equation for the hyperbola will come out to be r equal to 2 secant 2 theta cos theta, or r equal to 2 cos theta secant 2 theta. Order is not important. Both are correct. Now last step is to do the polar graph. For that I will again go to the next slide and show you the graph. We can use the long method of table of values, change my angle and get my r from the calculator. So use your calculator and evaluate the function r equal to 2 secant 2 theta cos theta for different values of theta. Change your theta, you will get different answers. For r, take all the points and plot them, and this is how your hyperbola graph will look like. Okay, it's the same graph, it's just that now it is in polar form. So that completes the learning objective 16, where you learn how to convert between polar and rectangular equation, draw the graph, support your answer, and also check the rectangular equation. Okay, so before I move to the next learning objective number 17 of FRQ, I would like to do one last question just to make you more confident, which is of this. Now think, this is just like y equal to mx plus b. So can I say this is the graph of a straight line? Yeah, from rectangular equation, and here if you see the slope is square root 3 and there is no y-intercept. So this line is going to be just passing through the origin 0, 0 with the slope of square root 3, and it is not meeting the y-axis at all. Okay, now let's go on further and convert this to polar form. So I'm going to replace x with r cos theta, y with r sin theta. And let's see what we get. For this question, if you see r is going to cancel, there is no r. So what is left? If you see, I can just divide both sides with cos theta. And why I do that will be evident to you in a minute, because cos cancels and I'm left with sine over cos, which is the quotient of tan. If I divide sine with cos by term 2, trigonometric identities, we have quotient identity, sine divided by cos is tan, so tan theta is square root 3. This is what I get. So I can exactly get my theta from here. It's going to be tan inverse of square root 3. Do this in your calculator and you will get pi by 3 radians. So theta equal to pi by 3. This is my polar form, and this is an interesting polar form because it does not have any theta. So can I say that the graph of this polar equation, theta equal to pi by 3, will again be a straight line passing through the angle pi by 3 for any different value of r? So whatever value of r I will take, my graph for theta equal to pi by 3 would be a line which is passing through the pole definitely with different values of r. So let me show you the graph. I'm going to the polar grid now, and this is how your graph is going to look like. Let's check your answer. The final graph is going to look like this. As I already explained to you, it will be a straight line. So y equal to square root of 3. This was the rectangular equation given. When we convert to polar, we got theta equal to pi by 3. So if I change my value of different r, my angle theta is fixed. So if I go to this line, see, this point is my pole, I go to pi by 3, this is positive r. If I make it negative r, it will be in the opposite direction. So it's this line, theta equal to pi by 3, passing through the pole, and therefore, as you can see, again, it's a line. So this is the final graph.